Okay. Edexcel practical 1, determine the acceleration of a freely falling object. Let's see. Method 1. Using an electromagnet. Look, here there's electromagnet. And here there's a ball. We can let this ball freely fall. We can let it to free fall this distance. And yes, there's a detector. Timer is also there. So let's see what we are going to do now. Open switch to break connections between battery and electromagnet. We open, that means off this switch in the primary circuit and turn on the timer in the secondary circuit. You know, when you switch this off, no current flow. When there is no current flow, electromagnet stops. Magnet is not magnetified then. So the ball is not stick with it, it will fall. When the time you switch off, you have to turn on the timer at the same moment, because that's the initial moment this ball starts to fall. Electromagnetic demagnetize, causing steel ball to fall a distance h from the bottom of the ball to the top of the trapdoor. Okay, it starts to fall like this. H is measured using ruler. We can measure the height. When the ball falls through the trapdoor, it breaks the connection of the timer. Okay. Here there's a trapdoor. Here there's a trapdoor. When it goes through this, they say it breaks the connection out. This timer is also connected to a circuit. When current stops through timer, it stops. So when the ball comes and going through the trapdoor, at the moment ball is here at trapdoor, this timer stops. The battery hence the timer. From this method, we can measure the time it takes really from here to here, because we switch on at once. Now, when we switch, change the switch, this starts to falls at once, timer starts, and when ball comes to here, the timer automatically stops. So the time is measured accurately. Okay.
Yes.
Record the time taken to fall h meters t. Repeat process 3 times. Discard anomalies and find average t. We can take, we can do triplet of the experiment and take time. Vary h and record corresponding t. Then we can even change the height and record the time takes by triplet experiments. In science, we always do triplets or more than triplets for the same reading. That's a must to avoid anomalies and to take more precise, more accurate answers. Given that S equals h, u0, acceleration is gravitational acceleration, time taken is t, you can use S equals ut plus half at square to measure gravitational acceleration, simple g. Plot t square against h. Now, Normally we use graphical method for more accurate answers. So you take this t square equals 2 over g h type equation, and you have all the data. You did several practicals by taking several heights. Then they say a graph t square versus h. It's y equals mx type graph. So you will have a graph like this with several data points around like this. All the data points are not in the same way when you do it practically, but you can search for a best line, best fit line which goes through the zero and which is symmetrically divide the data points and which goes through the most number of data points. You take the line. Then you can just take the, we say, gradient of this. Remember, in the exam, when we do questions, I'll teach you in the exam. When you take gradient, don't take small heights like this. Don't take. Always take the biggest amount you can. Biggest delta y, biggest delta x, largest delta y, largest delta x. Always take the largest. M equals delta y over delta. Don't take small values, because to increase accuracy, we have to take the largest we can. And when you know the gradient, here gradient is 2 over g. Yeah. Gradient m equals, gradient is m, 2 over g here. 2 over g is the gradient. So 2 over g equals the gradient we get. We know gradient, we know 2. You can calculate gravitational acceleration from it. That's how, using this method, we can calculate gravitational acceleration. Safety. If dropping off of a table, clamp electromagnet stand to table to prevent it toppling off. Okay. Be aware of falling ball. It's a tray to capture the ball at the bottom. Small currents, this is circuit. No danger of electric. Yeah, we use very small current. So electrically there is no issue, no safety issue. Evaluation. Small t values. Use larger distance to reduce uncertainty. Yes, you know, in the measurement knowledge, we know we have to take as bigger, as larger values or readings as much to avoid percentage errors. To minimize percentage errors, we have to take as bigger values as much. The bigger the value or reading, the lesser the uncertainty or the error. So that's a good one. Time delay. Between the timer starting and the ball being released due to residual magnetism in ball. Use a lower current so that the electromagnet, yeah. When we use a lower current, electromagnet has a small magnetic power. So at the moment we off the switch, it releases. But you know, if it is a big magnet or if the magnetic power is very big, even though we off the switch, even though magnetic power released due to the magnetism, high magnetism, ball may stay little more wide with the magnet and release. So it affects the reading of the time, accuracy of time reading. So they say one is use some material which gives less magnetism and also use small currents. No air resistance, not faster. Now we don't consider air resistance. We think we did this in vacuum. We don't do this in vacuum, but we assume air resistance doesn't affect. Method 2. Actually, this method 1 is the common one, which comes to the exam. I mean, that's the way. But there's another method in the short note. Using a trolley down a ramp. Let's take a look at it. Trolley. Okay. Trolley is there, ramp is there. Keep it to a certain height. Okay. Light bulbs. Clamp stand. Attach a card to top of trolley object and measure its width using a rule. Okay. This is the card they are saying. This is the card. Release it from top of RAM and start the stopwatch. When you release, just start the stopwatch. Stop. Light gate at the bottom of the ramp will record the time for which the card passes through. Can it? Light gate records the time where card is in it. That's why we use a light gate. So the time for which the card passes. Calculate instantaneous final speed of the card as length of the card. Now here if you take the card like this and light gates, you can say light gates limits like this. Let's take card in red. Now card enters the light gate, light beam, and it goes away like this. So, the light gate measures the time it is inside. There is a V1 velocity, V2 velocity increases. The light gate measures the time card is inside this. That is what it does. So actually finally we see no, we will, it's like this. Now light gate, don't think that light gate has any width. It's just a light beam. So it enters and card goes away. So it measures a time. The time is to just, if this is distance, the time is to just pass the width of the card. So the light gate measures the time it takes to pass the length of the same card. So we take the velocity length of the card divided by time. Gives its velocity. Once the card reaches bottom of the ramp, stop the stopwatch and record time taken. Repeat procedure 3 times. Discard anomalies and calculate mean time. Vary V by reducing distance of trolley from bottom of ramp. The record and record the respective values of T. We use V plus GT, plot V against T. Yeah, same things. Yeah. The method is okay, but it's not a common method. Look at the third method. Free fall of a card. This is again asked in Excel. This is someone asking. It is the addition of first and second. I mean, it's a free falling. All the theories we discussed under free fall is there, but we use a card like the second one, not just a ball. So you just release the card, you know the length, you know the height. When you release at the moment, you have to switch on the stopwatch, and but no need to take initial, no need to take whole time, because card goes and there's a light gate. When the card goes through the from the light gate, it measures the time card takes to move that distance of its own length. So we can measure length and the time. From that we can measure the velocity of card at this point. So from the when we know the velocity here, we know the very initial velocity is 0. We know the distance from the ruler. So using v square equals u square plus 2s, we can calculate simple g. In all the ones, you can use a graphical method. Also, you can do by changing this s distance, you can take different readings and draw a graph and finally take the answer. Here, if you draw the graph, it will be v square into s, y equals x. It's also y equals mx type graph. So you will get a graph like this, and then you can take the gradient of the graph. Gradient equals 2 into a. 2 into a means here acceleration means gravitational acceleration. So you can take 2g, and that's the one. That's it. That's the practical. Do you have any questions?